In this lesson, we're going to explain the continental drift hypothesis and the evidence that supports it, explain how the theory of plate tectonics relates to changes on Earth's surface, and identify the three types of plate boundaries. Let's get started! The idea of entire continents or land masses moving around might seem pretty hard to imagine. In fact, when it was first proposed, people didn't believe it at all. The first person to come up with this idea was Alfred Wegener, a scientist who noticed, just like us, that the Earth's continents kind of looked like a big puzzle. He believed that the Earth used to just have one supercontinent called Pangaea that slowly drifted apart into the 7 continents we know today. Alfred called the theory continental drift, or the slow movement of continents across Earth's surface. Unfortunately for Alfred, nobody believed his theory of continental drift. After all, it's pretty hard to imagine entire continents just drifting across the ocean. But decades after Wegener's lifetime, more and more evidence began emerging that supported his theory. Fossils of animals only thought to have lived on one continent were found on the other side of the ocean, too. Then, scientists realized that the rocks the fossils were found in also matched. Here's an example. There are nearly identical mountain ranges made of the same kind and age of rocks in Europe and North America. How do you think that happened? Discoveries like these gave scientists some hard questions to answer. Did these mountains form at the same time in different locations? Or did they form as one mountain range that drifted apart? Continental drift was starting to sound more plausible. But the problem with Wegener's theory was that it didn't explain how the continents were moving. That's where the theory of plate tectonics comes in. This theory started out with scientists who study earthquakes. They used to think that earthquakes just occurred randomly all across the planet. But as technology got better and better throughout the 1900s, scientists started making tons of new discoveries. They invented a device called a seismograph that converts vibrations in the earth into electric signals and used them to learn more about earthquakes as they occurred. The seismographs showed them that these events in Earth's crust usually only happened in certain places, and they happened in those places over and over again. By mapping out the lines along which the earthquakes tended to happen, scientists mapped out divisions in the Earth's crust. The theory of plate tectonics states that the Earth's crust is made of about 20 of these separate pieces called tectonic plates that slowly move over time due to currents of heat from the planet's core. So, how do you think the theory of plate tectonics changed the way people thought about the theory of continental drift? Scientists started to see how these two theories are closely related. Basically, plate tectonics are the cause, and continental drift is the effect. Alfred Wegener's theory started to make a lot more sense once we had an idea of how it could be possible for a continent to move. There are places along the edges of tectonic plates where we can actually see how the Earth's surface changes as a result of this movement. These edges are called plate boundaries, the area in which tectonic plates meet. There are 3 different kinds of plate boundaries, one for each of the 3 different ways they can move. The first is called a divergent boundary. Diverge is another word for separate, so a divergent boundary is a place where 2 tectonic plates are moving apart from each other. As they pull apart, the movement often causes earthquakes and creates areas where molten rock from the Earth's mantle can rise to the surface in volcanoes. Over time, water rushes in to fill the new gap in Earth's crust. In fact, there's a place in Iceland where you can swim between two tectonic plates in a divergent boundary. Pretty amazing, huh? The next kind of plate boundary is a convergent boundary. Converge means to come together, so you guessed it, this kind of boundary means that two plates are colliding. When this happens, the denser plate will usually be pushed down underneath the lighter plate and melt, leading to volcanic activity. This lifts the lighter plate upwards, resulting in powerful earthquakes, but also creating huge mountain ranges, and sometimes even bending the sea floor to create deep trenches. The deepest trench in the oceans, the highest mountain on Earth's surface, and the most active volcano in the world were all created by convergent boundaries. And the last kind of plate is called a transform boundary. This happens when two plates are sliding past each other. These boundaries don't create mountains or melt down tectonic plates, but the constant grinding past each other does create a lot of earthquakes. The San Andreas Fault Zone in California is a transform boundary, and it is one of the fastest changing plate boundaries in the world. It moves about 2 inches every year. It might not sound all that fast, but over time, it's enough to move continents. And yes, that does mean that the continents are all still in motion today. Scientists think that in the distant future, they'll all merge together again to form another huge supercontinent. But they aren't exactly sure what it will look like or where each continent will end up. But don't worry, we'll only need to wait another 100 million years or so to find out. So, let's recap what we learned today. You now know that the continental drift hypothesis says that the continents are moving and is supported by evidence like the fossil record and rock formations. The theory of plate tectonics explains that the Earth's crust is divided into slowly moving sections, which results in constant but slow changes to Earth's surface. And there are 3 types of plate boundaries: divergent, convergent, and transform.